Hello, welcome to my channel. Today we're going to be cup stacking and talking about coral. We're going to be talking about what coral is. Yeah, let's get into it. So first off, coral is in the domain in Eukarya, the kingdom of Animalia. So it's animal, which is surprising, which not a lot of people know. And it's in the phylum Nidaria, which basically means it has stinging cells. It's jellyfish are in the same phylum. So let's get into it. So let's set it up. First off, coral is typically limestone or calcium carbonate base with animals attached to it. The animals are called Zooxanthellae, which are the animal part of the organism. Zooxanthellae are also called coral polyps, so I'm going to be using those terms interchangeably. These coral polyps are photosynthetic, which basically means they can photosynthesize. Photosynthesis is a really cool process. It allows the organism to take the sunlight and transform that into energy. So it would be like if we could take the sunlight and make food out of that. So it's basically using sunlight as food. Now the cool thing about these polyps or Zooxanthellae is at night when there is no sunlight, they have these tentacles that pop up and flow in the ocean that can actually filter out plankton and other microorganisms and uses that to eat as well. So it can photosynthesize and it can also digest food, which is pretty cool.
Now we're going to talk about the types of coral. There are generally two types of coral, that being soft coral and stony coral, which can also be could be referred to as hard coral. So let's start out with soft coral. They're in the order. I have to look here because it's hard to pronounce. Alcyonnakia. Examples of this is fan coral, which I'll put up a picture of right here.
It just looks like a fan. That's why it's called fan coral.
Soft corals don't actually structurally benefit the reef, but they're a good sign of a healthy reef. These corals are the beautiful corals that flow back and forth in the water column. These soft corals are way more delicate than stony corals. The other type of coral is stony coral. Unlike soft coral, these coral are able to support reef, and these corals are what reefs are built on. Examples of these is brain coral or Dipolia labyrintha.
It's named for its brain-like features. Also, what's cool about it, the scientific name, labyrintha, as you can see, the formation is like a labyrinth on the coral.
Staghorn coral, Acropora cervica.
It's named for its features of looking like a stag's horn.
And Elkhorn coral, which is Acropora palmata.
You guessed it. This one is named Elkhorn coral because it looks like an elk's horn. What's cool about this one, just like the brain coral, the scientific name Acropora palmata is named palmata because, as you can see, it looks like a palm of the hand.
Let's just finish off this set, and then move on to the next one. Okay, so now I'm going to explain why hard corals or stony corals are better for building reefs and more sturdy. For one thing, it's a calcium carbonate skeleton rather than limestone backbone. The calcium carbonate is stronger than limestone. The Zooxanthellae are typically stronger and more sturdy on hard coral than soft coral. Because of this, they're responsible for protecting the coastline from big waves. They're able to break the waves, break big waves up. So let's say this is right below the surface of the water, and this is a wave. So it's gonna come up, but it's gonna break. It's gonna break, and it's gonna break right here. So it loses all the momentum. So that's why coral can help prevent storms. Okay, let's try to break the record now. Okay, ready? One try, and we need to go. That's ready. Set. $23.25. Okay, I'll see you next week for another video. Don't forget to like, comment, and subscribe, and I'll see you later. Bye.